So today's topic of discussion, welcome to my channel, is a continuation of particle wave amplification. And I want to shift the way I'm thinking about it a little bit, so that way we can add in the thinking of other forces involved. So when we're talking about the amplitude or the frequency at which the wave is moving, the resonance, the amplitude, the pulse, however you want to conceive of that particle riding on that wave of energy, the particle's moving through space. The particle itself is made up of energy. The particle itself is an energetic field event. It is moving in space. Even if it wasn't moving on a wave of energy, the particle itself is still jiggling in motion because it's made of energy, and energy is in motion at all times. It'd be extremely difficult to stop energy from being in motion. We conceive of absolute zero as the point where electrons stop moving in time and space, but that would be extremely difficult to achieve. So we're not going to talk about absolute zero of any more effect, because the particle itself defies the ability to reach absolute zero. So bypassing that, the particle's energy is in constant motion. If the particle is moved by a secondary force, say the particle has a force applied to it, and the particle is now moving through time and space, the force applied to it can be conceived of as the wave. Now, the speed at which the wave is moving, the amplitude, the frequency of the pulsing of the energy can be thought of, and we think of things like hertz and stuff. How many times the cycles of energy happen in one time segment we call a second, typically. Pulses per second. And then we have to think about the other external forces that might be being applied or are being applied to said particle. Are there other particles in the way? Does the particle have to move through resistance of passing those particles? Do those particles have gravitational effects? Are they pulling? Are they pushing? Are they trying to engage their electrons and things with the particle that's moving through time and space? The typical format that I like on this one is thinking about Einstein proving the photovoltaic effect, where when a photon hits a mirrored surface, it gives up an electron and it steals an electron, punching a really tiny hole in that mirrored surface, because it's taking an electron. It's also giving up an electron. It's basically breaking down that surface just this insignificantly small amount. Thus we get reflections in light. That interaction has to do with the particle of the photon engaging mass and then redirecting itself in another direction. The density of the mirrored surface gives the photon somewhere else to be. In other words, as far as I can tell, the path of least resistance is to bounce off the surface and to move in another direction. Now, I could be completely wrong on that. Richard Feynman worked for decades on these problems, and I don't research his work much. And I don't do the mathematics on Einstein's work, on why the photovoltaic effect worked. But basically, in the transition of the reflection of this photon, the photon's engaged another substance. And the photon's now moving at it in a different direction. That transaction of an electron shift, giving up an electron, taking an electron, uses energy. There is no way to get around it. No transaction of matter, to the best of our ability, comes free in understanding. There's always a loss in translation. There's always transitional losses. Translation losses, sorry. The ability for a particle to have energy applied to it and to move through space, and then it has to interact with other particles, uses energy. There's just no other way around it. There's forces, there's friction, there's strong and weak nuclear forces, there's what we would call gravitational forces, there's energy losses from transmission and interaction with other things. Friction's a big one. So in thinking about this, what we're talking about is amplifying the wave the particle is riding on while reducing the friction in front of it. And this is really hard for me to describe. But if we can reduce the friction in front, the interaction with other molecules or particles, we can reduce the resistance, and we can increase the frequency or amplitude range of the wave. We can get the particle to move faster. Particle wave amplification, the thinking on it, has to do with catching other forces that are currently available that we don't normally think we can use, and increasing the energetic effect of the wave or the particle. In other words, we want to time it to jump its energy or its motion while reducing the friction to a negligible level. There are forces around us that are really hard to describe. Gravity is really hard to describe. Entropy is, we have descriptions for them, but they're really hard to take effect of. So how do we get things like magnetism, because everything is in the electromagnetic spectrum, for light at least. How do we get magnetism to engage the particle's wavelength? How do we get to amplify the wavelength of the energy moving the particle? How do we time it so this effect multiplies itself? Because basically we're looking for multiplication and jumping the oscillation or the frequency at which the waves pushing the particle, we're trying to think about the effects of interaction with gravity, with light, with mass. Are there energy outputs or torrid magnetism waves? Can we catch on to those torrid waves? Can we catch on to the timing of the magnetism or the underlying wave of energy output that's moving consistently throughout the universe? That's really difficult to describe because it doesn't make sense. But there's underlying energy outputs. It's like, again, it's like density. We're thinking about energy density and how there's slow forms of energy, there's medium speed forms of energy, there's fast forms of energy, there's high frequency forms of energy or really fast forms of energy, and then there's things like light, the frequency at which moves extremely fast. And we're talking about catching those subtle frequency timing events, because all things are made up of energy, and all energy has to be calculable. We're talking about catching the events of the slower energy cycles and using those to amplify the wave of the higher energy cycle in a timing event. I'll give an example of how I'm thinking about this. It has to do with music. And this is not going to translate properly because it's really difficult to conceive of this in the ultra low frequencies. So if you're playing a guitar and you have another guitar right next to it, and the guitars are of an equal size and volume and have equal strings, you hit one string and the resonance frequency of the energy hitting the other guitar will cause a harmonic vibration in the other guitar, which has not been touched. Now, that's because the frequency at which that string resonates is equal to the string that's being strummed, and the energy output from the strumming of the string is now interacting with something that is harmonizing with it. This thinking process is what I'm talking about. How do we find, because there's two strings on the guitar that are equal, oddly enough, and they're both E strings. There's the first string, which is E, and the sixth string, which is E. So the first and sixth string are equal keys, but one is in the lower octave, one is in the higher octave, but they both resonate to each other because of their frequency of E. What I'm saying is, can we figure out the lower frequencies of energy that are near entropy, the entropic loss of energy, the subtleness of that energy? Can we catch it like a wave? And can we catch on to its pulses? Because its pulses are much slower. We're talking possibly thousands of times slower. Can we catch the resonance frequency of those waves of energy and then build upon them with our higher frequency waves of energy? And so it'd be like you hit the key of E, the other string resonates, and you keep hitting it until the other string is resonating at a really high frequency without having to interact with it. The other guitar is also interacting with that force, and it is up-regulating that frequency. So it starts harmonizing. Now, that has to do with, here on the planet Earth, that has to do with particles close to each other, the density of the mass, in other words, air, the ability to hear or perceive that energy moving through the air. But if it was a vacuum, would it happen the same?
Wait.
And can we catch on to those event cycles in a similar fashion? Certain forms of energy are not going to translate this way, because in space, with the absence of other molecules or atoms to engage, the energy is just going to dissipate due to distance from the source. And that's the inverse square law. So the further away from the source, the less interaction there's going to be, because the wave is losing density. The energy wave is losing density. But with that being stated, can we catch the entropic loss? Can we catch the wave? Can we catch the lower frequencies and use their effects to increase the frequencies at higher levels? Very interesting to think about. I don't know if I've described that properly, but if you have an idea about how to describe it better, or you have some thinking on it that you want to share, you can leave a comment in the section below. You can make a video about it and share it with me. You can share this with your friends. Or you can say just about anything you want concerning this topic, because I'm not saying that I'm right. I'm saying this is conceptual. How do we do something? How do we figure an issue out and go from a problem to resolution of a problem? And that, for me, has to do with reducing the energy consumption on the planet and giving us a different form of propulsion. Have a great day.